Hey guys, I've changed my SID tunes today. There's a little video in the bottom corner now, just kind of there somewhere, so you can actually see what's playing. I can hear myself, that's annoying. I need to turn that off, hang on. Why have I got that on? Oh, it says monitor. Oh, I've got my own stream on, that's why. There we go. Alright. Hi guys. So tonight we're going to do a bit of Parallax. So we're going to start by taking a look at a couple of games. 3 games actually. Parallax, which Hayes has been playing tonight. Then we're going to look at Nebulous as well, assuming I can skip to the later levels. I've not actually tried yet on that. I'll explain why when I load it up. And then we'll look at Flimbo's quest. We'll try and do that fairly quickly, because when we're done with that I want to try and show you how to do some of those techniques. We'll probably manage to do the Parallax from Parallax and the Parallax from Nebulous combined, probably. That's my aim anyway. I've prepared some charpad files to do that, and I doubt we're going to get time to do the Flimbo's quest one, but I can explain how that works in a bit more detail when we get into that. And you'll see why it's going to be difficult to kind of do that. Also, my camera's pointing at weirdness. There we go. You don't want to see my camera. You don't want to see my microphone arm. I want to see that. I should get Sprite kind of product placement. I don't. Oh, sorry. Set my phone on. Gotta put my phone on mute or else it will start beeping like crazy. So we've got it. Hi Mr. G, hi Andy, hi Buzzley, Colt45, Twin Zen, Stepz, Nulapetus, Chris. Sorry Chiz. Chiz Wicked, not Chris Wicked. He's been having a hell of a week with that. I believe you got Chris like twice yesterday, Chiz. It's becoming quite a thing. It's a very easy name to misread. Okay, let's start by loading up Parallax into the debugger, and I'll show you what's going on there. Hi, Mad Beagle. Welcome to the stream. Hopefully I've got my sound on right. Let me know if the music is too loud as well. I wasn't sure what volume to put that video on, so, and I can kind of just about hear it. So let me know if it's too loud or too quiet or whatever. I've not figured out what the volume should be yet on it. Hi Sinlao, welcome to the stream. Is this the right game? Ah, yeah, it is. There we go. It's got this interesting raster effect going on here. Although not with stable rasters, which would irritate me. All this bendy stuff over here would kind of annoy me a little bit. But it's fine. This screen's actually quite interesting. I was watching this on Hazy's stream, because that's actually doing inverted characters and then parallax scrolling backgrounds, which means the stars that move over the top are also either inverted or they're probably multicolour actually. Oh, is my stream still there? Yep. It's kind of behaving a bit funny tonight. I think it's OBS just being a bit strange. Hi Amok, welcome to the stream. So, the parallax effect in Parallax is probably the simplest of the 3 approaches we're going to look at tonight. There's a few different approaches to parallax. These are the 3 most common that we're going to look at now. Let me just start the game and quickly pause it. So Actually, let me just take off so you can actually see the parallax going. Remember how to take off. Backwards, there we go. So you can see that grey pattern in the background is moving at a different rate to the rest of the map. So this effect is fairly easy to do, although they have done it in all 4 directions, which is nice. It's a little bit trickier to do it in 4 directions. Let me find the right screen. I can never get this screen right first time. There we go. So the first thing you'll notice is that all these, actually it looks out of place because we've scrolled across slightly, but the background tiles fit exactly into a 2x2 block, and they should be in here somewhere. Let's see if I can find it. Actually, we'll see it. If we just start the game, we should see it moving. I think it's these ones here. See it scrolling around here. These 4. So if I was just to draw, it's not going to let me draw, is it? No. Okay. Can I at least turn multicolour mode on? That would be kind of nice. It says multi, but it's not on multicolour mode. To be honest, the font thing in here I'm still not fully familiar with, but basically what's happening is these 4 characters make up a block. I'll show you in here. So you imagine a block like this. Let's just do a square, for instance. This isn't the most interesting thing to watch, but you'll get an idea what's going on. So the way this works is if you create a tile out of that, and my tile editor is going to be right down here in the corner, isn't it? No, it's not. Where is it? Tile editor. Tile editor's not on. There we go. So do a 2x2 tile. Okay. Here's my tile set. So if I create a tile in here, and it is all the way down here, that's annoying. Oh, come on. It really has some weird things in this, weird behaviours in this tool. So you imagine this tiling pattern all over the screen, and then you've got some other tile which is not, let's just put some junk in here, it really doesn't matter. Let's make it kind of distinguishable. So if this is the map on the screen and you've got some kind of platforms like we do have in Parallax, so you've got these areas, these platforms. The way that the parallax works is as the screen is scrolling, everything will scroll. So you'll get, if you can imagine this, I can't make it any smaller, that's a bit annoying. Actually, let me try zooming in, there we go. So as the screen is scrolling, everything scrolls together. So obviously that doesn't create a parallax effect, but if at the same time what you do is you shift these objects, you shift these all along, like so, you can create the illusion that the background is moving at a different speed to the rest of it. It's not the easiest way to explain it in here, so let's have a look at the game again. Let's slow it down a little bit, and you'll see what I mean. So, where's my speed up button? There you go. So you can see how these characters are just being edged ever so slightly in the opposite direction to the scroll. So that instead of moving at the same speed, they're moving and then moving back a little bit. So like for every 2 pixels that the screen moves, the tiles move back 1 pixel. And that's a fairly easy thing to do because we have bit shifting. So if you've just got a value in memory, so if you've got a, say your value is there, Let's save this as ASM so it actually shows up. Just call it start ASM. And you want to shift that value. All you have to do is shift it to the right or shift it to the left. Obviously the last bit gets put into the carry bit, so if you want to shift to the left, you would do this, and then you have to check the carry bit. If the carry bit's clear, then you go past it, otherwise you add 0. I mean, you can even just skip that and just do the add, because it will be in the carry bit anyway. So that's absolutely fine. And that will shift this bit, so that what this will do is if you've got 1100 1100 and you run this piece of code, it will actually end up like that. Any bits on this side get put onto that side, and you can keep doing that. Now it's a little bit different in the other direction. So if you want to shift to the right, for instance, can you Alt and enter the debugger window? I can, yeah. Hang on. Let's just demonstrate this in the other direction. So if you shift into the right, this is what happens. Okay, so you've got. Let's do. Now if I shift that to the right, that's going to end up in the carry bit, and we need to put it here. Now you can't just add a value because it's not going to work, because we need to add 80 to it. So this is where you do actually need to do the branch, and this is the simplest way to do this, like that. So what this is saying is shift everything across to the right by 1, so that now creates this, and this is in the carry bit. If the carry bit is clear, don't do anything else. So if that was a 0 on the end, a 0 gets put on that end automatically, so that's fine. However, if it's a 1 on the end, it goes in the carry bit, and so we just OR 80, which will then stick it back on that end again, like so. So there are two slightly different techniques for shifting left and right, but I mean, this is about as quick as you're going to be able to do it without using, in fact this is as quick as you're going to be able to do it. To go up and down is a little bit different. To go up and down, you would create a loop, like so. I should indent these things, it's a bit easier. And you would load all the characters, or all the bytes that make up a character. So you would take this, and you would store it at, like so. Now obviously, to loop these round, what you need to do is not do the very last one here, and instead what you can do is you can load that here and store it back at the top there. So you're taking the bottom row off, storing it in the Y register, then you're looping through the top 7 rows, copying them down 1, and then when you're finished, you're storing that value back in the top row. And to go the other way, it's pretty much the same thing, but in reverse. In fact, that's not. Hang on, 6. You would have to do it like. Hang on, let me think. Is it? Oh no, that would work. Yeah, sorry, that would work. And to go backwards, you would have to do it the other way. So to go backwards, you would have to count backwards. Well, you count forwards in this case. Like so. And this would just be the other way around. So you take the original value and store it at the bottom. So there you go. This one scrolls. So this is scrolling to the left. This is scrolling to the right. This is scrolling down, and that's scrolling up, like so. Hi Mythical Duck, welcome to the stream. Oops, hit my microphone. Oh, it's really warm in here. 6502 is the power of 6502 making me warm. Oh, Turbo Outrun's playing, and I can't hear it. That's annoying. Brilliant tune. Okay, so I'll keep this file in there because this is. Let's rename it. Let's call it char shift. Just so you guys, because all this will get saved to my GitHub afterwards. My GitHub link, for those who don't know, is there. It has the code from this stream, all my Dissect streams, well, the ones where code was kind of generated that I saved. Oh, that's gassy that. And also, where's my inhaler? One sec. And also my code from my game streams as well. This is just another video from YouTube that I downloaded about 5 minutes before the stream started. So, well, maybe 10 minutes before the stream started. So hopefully there's nothing lewd in the middle of it. I would hope not. It's a bit short. It's only 6.5 hours of music, but I'm hoping it doesn't have Masters of the Universe quite as often as the other one did. So left and right only do one row of the chart. Yeah, that's true. So if you wanted to do a whole chart, you would have to do like this. Let's actually finish. That's a very good point. And they also don't store back where they should be storing. So you go. That does left. Right, you can do with pretty much the same approach. Also, it's worth noting as well, if you are just doing a left and right horizontal scroller, sometimes you don't need to scroll every line, so it depends on your design. So for instance, if you had a single character that you were scrolling that looked like this, oops, then actually you only need to scroll 6 lines. It's pointless scrolling this line, it's pointless scrolling that line. You could even just scroll this line and then store the value in all of these. So you can find ways to optimize it even further. One thing I'll show you before we continue as well is actually let's call that loop, is how to scroll from one character into the other as well. So this basically is for a single character, so this wouldn't work for this. This is for this entire square. It would only work for one character. If you want to scroll from an entire square, you need to do something slightly different. So I'm just going to do it for the left, and you can I'll leave it as an exercise for you guys to work out how you would do it on the other sides as well. So to scroll 2 values, if you imagine like so, and actually let's change it slightly so it's not an exact copy. So this is the 2 characters that we've got side by side. The end result needs to look like this. So everything is being shifted to the left, and this byte here is being moved all the way around to the front here. So the way you would do that is you would, let's imagine this is starts at C00 like so, and this starts at C008. You would start by taking the value on this side and shifting it to the left. That would put this byte into the carry flag. Then you would roll the value in fact you can do this like this, I think. I don't know if ASLX works. Let's just do it like this because we do need to put this value back again. You would roll the value in here. Now the reason we roll is because roll will move everything across, but it will also take whatever's in the carry flag and put it in the bottom here. So this will shift this one to here basically, and then whatever the carry flag is at this point is what this was here. So you can just do this again, add 0, store it here, like so. And that will shift 2 characters. So the only difference is you just use a roll in the middle to move that byte from here to here, that bit, sorry, from here to here. So I'll leave that there like that. It's the same with the other direction, except instead of using roll left, you use roll right as well. Hi Doxter, welcome to the stream. I hope you're doing well. You got here a little late. It's alright, you've not missed much. So yeah, that's basically how this one works, and that's an effect that's used in a lot of games. I mean, this is a really good example of it because the game's called Parallax, but other examples would be Turrican uses it quite a lot, Creatures uses it a lot, Mayhem in Monsterland uses it, oh god, the list goes on. There's so many that use it, and there's different ways of doing it as well. So in this case, the background is moving in order to make it appear like it's just moving at a slower speed than the foreground, but some games will move it exactly the opposite of what the map has moved to make it look static, like it's not moving, which is an effect I'll show you when we implement this. I've got a plan for how we're going to implement this, so when we get around to that, I'll show you the different ways different speeds you can move it at, and also give you some tips on how to design your foregrounds and backgrounds for this as well. So you'll notice in here all the edges are very square. There's no curved edges anywhere, and that's because if there was an edge that didn't fill out the character completely, you would get a gap in this parallax, and it would look a bit odd. You'd see kind of black patches where the background tiles don't quite fit in. I try and avoid that, so in Doc 2 what I've been doing is deliberately making these backgrounds quite sparse. See that here it's kind of all filled in and grey, so you will notice a gap. If I show you on here, so for instance, if I scroll these halfway across, so let's put let's undo that, stick a pattern in it. Okay, so if I fill this out now, I've scrolled it all across, haven't I? Okay, so I fill this out with a pattern all the way through it. So it's quite busy. There's a lot going on in this. And then if I just change the colour of this, I do it like this first and change its colour to, is this global? Let's do it per character. Yep. Change its colour to grey, right. And change the background to black, just so it's, no, black please, there we go. So when it's like this, it's alright, because if this tile scrolls down, if I try and move this down here like this, in fact let me just do it with one character for now, it makes it a little bit easier to demonstrate the issue. So let me change that tile. Where's my tile editor gone? There we go. That one. Right, there we go. I'll get rid of the grid so you can't see it. So with a busy character like this, a busy pattern like this, you really do need the square edges. If you don't have the square edges, it's going to be very difficult to hide the fact that you're doing tricks. So here you can see, you know, the square edges, the parallax, it looks like it's going behind it perfectly, and no matter how I scroll it, it looks fine. However, if I was to take a chunk out of this on one side, like that, ignore the fact that it's copied all over. Let me just make another character, it's probably easier. Let's make it that colour, fill it in. Right, there we go. Oops, it's tiles, so I need to edit the tile. Oh, damn it. Make another tile over here. There we go. So you see now we've got this nice little edge on here, which adds a bit more kind of depth to it. Not depth, but a bit more detail to it. But as we move this pattern, you can see it's not showing in that black gap, so you can tell there's a cutout there and that the tiles aren't moving over it properly. So the trick is to try and keep these colours quite muted. So dark blue is kind of a good colour, and to make the patterns very, very simple. So instead of a busy pattern like that, you just want something very, not like that, something very simple and light, and not too detailed. And now when I move it around, even though that pattern is there, whoops, that's the wrong thing, I'm moving the map around there. Even though that pattern is there and the gaps are there, it's a bit harder to see now because there's a lot of blank space anyway in the tile. So it's a good idea to keep the colours muted, and to kind of keep the patterns quite light if you want to do more detail in your backgrounds and not have square edges. Cool, right, let's take a look at the second game, because I want to try and get through these games in not too long. I want to spend a good hour or so showing you how to implement these in code. What's the next game? The next game is Nebulous Soap. Okay, the reason I haven't tested this game is because I saw the intro for this. This is the one time I'm actually pleased about the intro that they put on it. I saw the intro for this and thought, well, this explains exactly what the Nebulous Parallax is all about, without me ever entering the game. So I basically spent the time ripping the graphics from it. Oh, hey! Oh, I can hear my alerts. Yep. Oh god, the quality of that audio is terrible. Hey Hayes, hey guys. You literally just missed the parallax explanation for Parallax. We're just going to take a look at Nebulous now. Hi guys, hi everyone, it's Come Along with Hayes. So those who don't know, I'm Shannon50k. I do C64 coding, games on Saturday. We work on a collaborative game effort, and on Thursdays we do Dissect, and I started to do a bit more kind of technique explanations, some coding demonstrations. Alert working sort of. Yeah, it worked, but the sound quality was awful. I think I need to fix the sound quality on that. Thank you for the follow. I can't say that name. Kyoka Sagani. I'll call you Kyok. Yeah, thank you for the follow, and thank you for the host Atkinfin, although the alert didn't come up for that for some reason. Hi Booney, welcome to the stream. Yeah, you just missed Parallax, so we're just explaining. I can give you a quick rundown of what Parallax is actually doing with the demonstration here in Charpad. So basically, as the screen scrolls around, the entire screen scrolls, including the background tiles. But then what you can do with these tiles is you can move them in the opposite direction of the scroll at a slightly slower speed, to give the impression that the background is moving independently. You can see there I'm just using Charpad to nudge the tiles along, and it gives the impression that there's two layers here. I was just explaining by making these tiles quite light, as in like mostly empty space, mostly negative space, you can get away with having more curved edges on things, which is something Parallax doesn't actually do. So thank you for the host, Andy Magic Nike, as well. Kyok. Kyo. Yeah, I like Kyo, that's better. It's better than Kyok. Yeah, so I just started loading Nebulous up, and I was just saying this is as far as I got with Nebulous, testing Nebulous, before I realised that actually this intro has exactly the kind of parallax that I want to demonstrate in Nebulous. So I've ripped the graphics from this, made some modifications to it, and once we're finished with kind of looking at how the games do this, I'm going to use these graphics to demonstrate how to do parallax. and we'll combine the parallax you see here, which I'll explain in a minute, as well as the parallax from Parallax. It's really annoying that they called it parallax as well, because when you're talking about it, it's difficult. I'll combine those two. I'll combine those two effects to create a single kind of parallax effect that uses both, and I'll explain why sometimes you might want to use one and why you might want to use the other. So I mean, obviously the reason you would want to use this is if you want a level which can move around over the background and isn't just on vertical strips. So if you have horizontal strips. So if you had a level that was just horizontal strips, such as this, where you've just got, you know, the patterns are moving at different speeds only in horizontal bands, you can use this effect. If you want that effect to be a bit more kind of all over the place and allow you to scroll the map around, then you'd want to use this character effect. This is definitely the most common parallax effect. As I say, it's used in so many games. It's also one of the cheapest ones to do as well. It's quite easy, as you can see from the code. I mean, you know, this is doing 2 characters scrolling. This is not a lot of code to scroll. All right, you have to do it for each direction, but again, it's not that much really. So this effect is a little bit different, and you'll see if I go into the character map, which can I remember? No, it says remember in massive letters, but I can't remember that. If I go into the character map, you'll see that actually there is no character set scrolling. There's a little bit going on down here. Can I actually place a marker? No. So you can see at the bottom, on the bottom row, there is some character set scrolling there, but that's nothing to do with the parallax. That's something I don't actually know what that is, but it's nothing to do with the parallax. All the characters for the parallax are these ones at the top here, and they're not being scrolled. As you can see, they're not moving, and it's the same. It's going to be the same in the game itself as well. So let's get into the game. Hopefully, I can turn level skip on because I don't want to have to try and complete the level. Oh, okay. It's a cool intro. It's a simple intro, but it's very effective. It looks nice. Yeah, I really hope I can level skip, because I really don't want to have to complete that level. I suck so hard at Nebulous. I love the game, but I suck really bad at it. Why is that not letting me skip on? Is it run stop? Is there a button? Oh, there we go. One of the most impressive parallax implementations I've seen recently is Sarah Jane Avery's new game. She's using 2 of the techniques here, as well as Starfield as well. So the Starfield is another kind of parallax, I guess. I mean, we touched on how to do one type of Starfield on the last trainer I want. Unlimited lives, yeah, why not? Infinite time, yes. Yes. Set my starting level. Well, I'm guessing I need the bonus level. Yes, CBM key, there we go. Yeah, the Starfield that we did in the last stream is another kind of like Parallax, but it's kind of more flexible than that. But it allows you to create layers. But she uses the character parallax, the kind of easy approach to parallax, but then she also layers in the Flimbo's quest style parallax, which I'll show you how that works as well. Do you think it'd be possible to have a capture of your game in the C64 Debugger and debug live code on real hardware? It certainly would be possible, I think, if they, I mean, I imagine the Ultimate has the tools to do that already. how you would actually connect that up to the debugger, I don't know, but I can imagine it could be possible if somebody really understood that. I don't understand the hardware enough to do it though, but I'm pretty sure somebody could do it. This is the one I was thinking of. It's my Amiga demo TriStar. Okay. Yeah, I think that is the same thing, to be honest. Looking at that, I'm just hovering over it, but yeah. It's certainly possible from the desktop to launch things on the Ultimate. You can control the menus very easily through Telnet. Acid Player 64, so this player here, I've not got my Ultimate turned on at the moment, but this music player will allow you to play SIDs from your PC, but through your Ultimate, and so you just pick a tune, and you can tell it to play through the Ultimate, and you don't have to have the file on the Ultimate. It will just launch it through the Ultimate. So I've been trying to look into how to get it to do the same thing with PRGs, and I think there would be a way to do it. So yeah, I think there definitely would be a way to communicate with it in that way. I don't know what it is, but there will be a way. Right, okay, let's see if we can get to that level. So apparently the CBM key should make me skip a level, so I'll get to the next level, then I'll pause it. Actually, is there any parallax in here? No, okay. Okay, that's not... Is it that one? No, that's my Windows key. There we go. Yeah, it wouldn't need USB. You could do it all over the network. The network functionality is really good, except for the fact that it will disconnect after too many connections. Like if you upload, it will stop connecting after a while. So you can see what's going on here is we've got multiple layers of parallax moving at different speeds. Let me take a snapshot so I can go back to it. No, what was the snapshot button? Quick store snapshot, shift control 1, okay. There we go. What's my restore snapshot so I remember? Control 1, okay. So you can see there's a static area here, and then there's 1, 2, 3 layers in the top, and 1, 2, 3 layers in the bottom. But you'll notice that these layers are completely contained within horizontal bands. There's nothing in the bottom layer that overlaps into the top layer, and so on and so on. And this is another fairly common technique, not quite as common as the scrolling charts technique, but it is still quite common. You'll see it a lot in Moon Patrol kind of games, Defender kind of games. Yeah, YouTube. Yeah. That overlay setting on the Ultimate is awesome. Overlay setting. Oh, didn't know what that was, but yeah. So this effect is quite common in kind of Lunar Land sort of games. I think Richmond might use something similar to this as well for his free 64 game, which if you've not played, you should go along and get it and play. It's a very cool little game. And he's using a combination of similar effect to what we were doing with the snow and rain last week, animating characters through the character set to create the snow effect, and then some parallax. And he does have an overlap between what appears to be the front layer and the layer behind. And the way that's done is by having a sprite. So if you had, say you had a bush here that you wanted to extend up into the layer above, you just create a sprite that you can move along. So now that sprite can move independently of the 2 layers, and you just move it at the same speed as one of the layers. So it looks it's like Christmas. Yeah, that's true. It is very Christmassy. So this is the second effect. So the way this effect works is with raster splits. I should be able to show you this in here. Actually, that's a good way of seeing it. So you can see Actually, let's just slow it right down. So you see, the scrolling is not smooth when it's in this mode. It's actually just shifting pieces of memory along at different speeds. So the outer bands move faster than the inner bands. And then it's using raster splits to control the hardware scroll for these locations. So if you look at the X scroll up here, if I just pause it, so X scroll is at 6 at that point, but as I move down the screen and then to different bands, you'll see that the X scroll changes. So the X scroll for this band is 1 and 4 here, and they'll probably match at the bottom here as well. So 4, 1 and 6. So what's happening there is you've basically got 3 different scrollers, 3 different map scrollers, but instead of scrolling the entire screen, they're just scrolling sections of the screen. So the first scroller is scrolling this area and this area, the second scroller is scrolling this area and this area, and the third scroller is scrolling this area and this area. And that means this static area doesn't actually need to do anything. It just remains as it is, as you'll see. There's no change to that whatsoever. This stuff just scrolls all the way through. Advantages of this is it's quite cheap to do. You're only really dealing with a couple of raster splits. You do have to scroll the data, but something like this, I mean, I'm not sure exactly how they did. Let's have a look if it loops round or not, but it's a fairly cheap operation. You know, you would do this anyway if you were scrolling a map. The difference here is you just have to scroll different areas at different speeds instead of scrolling the whole thing at one speed. UK steals all your snow. We haven't had snow yet, I don't think. Mike needs to make an Easter egg version. That would be good, wouldn't it? We need to convince him of that. Drop in Easter eggs on bunnies or something. Yeah, definitely. Okay, let's move on to the final game before we actually do some code, and that is Flimbo's Quest. And this is, in my opinion, one of the most impressive pieces of Parallax on the C64. It's an effect that's pretty well known how to do now. It was kind of probably first done with Hawkeye, I think. But it's used quite a lot nowadays to do these parallax in, because it does create the most impressive effect. And that's not, oh, it doesn't load from that one. Hang on, I need the one out of my folder. Although I do say it's used a lot, it is the least common, and there's a reason for that, which I'll show you in a minute. Also, I hate this intro. I don't know why. This intro really grates on me. Yeah, it's been a while actually since, I can't remember the last time it snowed. It feels like it's been some time though. It definitely didn't snow last year. And if it did, it was very brief, because I do not remember it at all. Also, this game has got amazing music. I absolutely love the music in this game. And I can't make my mind up whether this sounds better on an 8580 or on a 6581. At the moment, I'm kind of leaning towards a 6581 because of the bass in it. It's quite a kind of nice filtery bass. It works really well on the 6581, whereas the 8580 kind of makes it a little bit. It makes the drums sound a little bit funny and stuff. But sometimes the 8580 can have quite nice filters as well. But why is this not working? There we go. Yeah, so this effect is definitely the most impressive. It's also one of the most expensive to do, both in terms of cycle time and in terms of memory usage as well, and you'll see why in a minute. So, while it is used more than it used to be used, because it was quite an advanced effect, and I don't think people were quite confident using it back then. It's definitely used a lot more now than it used to be, but it is still... It's one of those that you really need to have the memory to do it. Sarah Jane's using it in Soul Force, and that's probably because by doing games on cartridge, you get a lot more freedom to mess around with memory that you wouldn't normally want to do. This game is multi-load, and probably this is partly why it's multi-load. They could have maybe fit, they didn't do the parallax background, they could have maybe fit 2 or 3 levels into a single load. So you can see it there, there we go. So when it's paused, it doesn't look that impressive, but when you move it, you can see we've got not just a simple pattern, but we've got like an entire background moving, and it's moving behind, behind another layer. We've got a transparent layer over the top. We've got a transparent layer over the top with vertical kind of pieces, and then this background is kind of slotted in behind it, and it looks really impressive, as you can see. I haven't seen any snow in Finland for this year. South Coast, wow, okay. Yeah, I saw a little bit in Helsinki when we landed, but that was it. There wasn't a lot. So let's go into the game and have a quick look and show you what's going on. So you can see it there very easily. We've got a background moving, or a foreground moving. Now, the first thing you can probably see is that all these foreground platforms are exactly square. They've been designed to kind of look a bit random and less square, but they are actually square. You can see the corners here are square, and that's because it uses a similar effect to the character scrolling that I showed you how to do for Parallax, but it's a little bit more advanced than that. So let's go and have a look at the character set. Well, there we go. Oh man, it's really difficult to see. Why can't I turn multicolours on? If anybody knows how to turn multicolour on in this mode, I'd be really grateful. I have no idea myself. Can I do it on here? No. Oh, I've died. There's got to be a way of doing it in here somewhere. So basically what's happening is, you can see here in the character set, you can see these characters shifting around. It doesn't look like they would be creating a parallax effect, but what it actually is the map is made of 2 maps. So you've got your foreground map and your background map. And first of all, the background map is drawn, and then the foreground map is drawn on top of it. But in order to scroll them at different speeds, you need to be able to scroll the background independently of the foreground. Oh, fell down a hole. And the way to do that is by having different character sets. So if I go into here, keep your eye on the character set pointer here. So let me just put that there. So this pointer here shows us where the character set is in memory. At the moment the character set is at E800, but if I walk, you see how it changed? It's gone to F800, and if you watch, it cycles through. That's because there's 4 character sets. Now, each character set has the foreground characters exactly as you see them here. I keep dying, it's not good, is it? The foreground characters never change, but the background characters do change. And the way they change, if I can go into, where is it? There you go, you can see it here. The way they change is they just shift. So every pattern is just shifted across in a character set by 2 pixels, and you do that over 4 character sets, and you basically get an entire shape that can shift 8 characters to the left, 8 pixels to the left, or 8 pixels to the right. So then what you do is, when you want to, oh god, where's that gone now? There we go. When you want to scroll the map, the background, you scroll the foreground first, and you scroll the background. Well, sorry, you draw the background, and then you draw the foreground on top of it. When you scroll, the values, your position in the maps change. The position in the map on the top changes twice as quick as the one in the background. So when you draw this, say you're all the way to the left, you'd be at position 0 in both maps. But as you move this way, your position in the foreground map goes up twice as fast as it does in the background. But for those steps that are in the middle, you just change character set. It's kind of hard to explain, actually. I just realised how difficult it is to explain that effect. I don't know if I'm making sense. So you see where it goes behind this post here. That's just this other character set. You see it moving here. It moves in here slightly. And you see the character set changing as we go. And that's all it is. It's just switching between 4 character sets really, really quickly. Unfortunately, it's going to be very difficult to demonstrate that in code in the time that we've got. So I'm not even going to attempt that straight away. If there is interest in that, maybe we can do that on another stream sometime. It would have to be the whole stream though, I think. It actually suggests it's 2 lines of code to do this. Yeah, this is definitely one of the more advanced techniques for scrolling, but it does look very, very impressive. Hawkeye is done exactly the same way, but in Hawkeye, instead of the background animating, is just static. So in Flimbo's Quest, you've got 2 maps that you're scrolling through. In Hawkeye, you've got a static background and then a map that's scrolling, and it's the static background just shifts like this, just shifts 8 pixels to basically cancel out the scroll of the foreground map. I love this game as well. I'd love to be playing this right now. Might have to play this sometime on stream because it is a really cool game. Although I won't be playing it in the debugger, I'll be playing it properly. Okay, so I'm going to take a quick break now. I'm going to come back in about 2 minutes, 2-3 minutes, and we'll try and implement some parallax effects. I've got some character maps already set up. I'll show you quickly. Pardon me. In here, so I took the characters from that intro. I made a copy of them, mirrored them, and created a screen that we can use. So we're going to use this screen, and we're going to try and animate it using the simple effect first. So we're going to do we're just going to scroll the entire screen first. Then we're going to we'll scroll it band by band. And then we'll implement raster splits to do individual X scrolls as we go. Many rows of the game and a big HUD. Yeah, so indeed, you'll see if you scroll in right in, you can see they use 7, I think. 1, 2, 3, 4, 5, 6, 7. Also, one of the other techniques that they're doing in here as well. So they are doing color scrolling because you've got these apples. You've got various things, like there's a ladder in here that's blue somewhere. Where is it? Yeah, so you've got this ladder here. So they are doing some color scrolling, but what they do, which you can probably see from here, is there's no color change in this top row of 2 or 3 characters, whatever it is. I think it's 2, yeah. And there's also no color change in this bottom row here as well. So they're only scrolling a fraction of the screen for color as well, and they're probably scrolling it in blocks, so you only have to scroll half of that as well. So there's a lot of little tricks in here to kind of speed it up, but yeah, I mean, it's only scrolling 18 rows, but I mean, it still looks good. It's a nice big sprite. It feels good. The game's well designed, so it works really well. So Chalan's Revenge, yeah, we should turn it into a game, shouldn't we? Alright, I'm gonna take a 2-minute break, guys, and then when we come back we'll have a play around with this. So I'll close that down now, and I'll be right back in 2 minutes. Oh, wrong button. There we go. Cool. It's because I've got a button labelled start, so I assumed it was that one. Alright, so what we're going to do, we're going to take this, we're going to save this screen out, and we're going to scroll it. So let's just save out all the characters. Export the character set first. We'll just call it chars. We don't need tiles here at all. We'll export the map as well, which is going to be our screen. What? Oh, I don't know why it's Oh, it's because I've got loads of space down here as well. It's alright. Got this screened up bin. There we go. Oh, I recognise that sound. Is that the ocean loader? I can only just hear it. So the background color is by using 4 chart. Yeah, so you displace. I'll just show you again quickly. You displace the background character set by 2 pixels at a time. From those quests, there we go. No, I wanted to load it. God damn it. And that means that when you draw the map, half of the character set is your foreground, the other half is the background, which is scroll. You don't scroll, you don't shift the foreground stuff. You just move the background by 2 pixels on each character set. There we go. Let's make it bigger again. It is a time killer, yeah. It is so. I mean, I've literally done nothing else for a few years now, since getting back into it. I absolutely love it, and it's been an interesting learning experience for me. And this is why I've kind of taken to streaming it, because I want to share the stuff I've learned with everybody else. Anybody can pick this up. You just need to spend some time to investigate and pull things apart and try and work out how things work and experiment. You'll make a lot of stuff that doesn't work, but then you'll make some stuff that really does work. So you'll see, if I just put a drop on here, this is the character set, and as I move, it scrolls through those 4 character sets very quickly, and the character sets look like this. So as I move, you can see each character set has just shifted that second half of the characters by a couple of pixels, which creates this effect here where some of them are moving independently of the foreground scroll. You can see it here on this platform. It's a very simple effect when you think about what's actually happening. It's expensive because obviously you're using 2 kilobytes for every character set, so you're going to use 8 kilobytes just for characters, which doesn't leave you an awful lot of room for sprites and screen RAM as well. So you have to kind of plan your game out to make the most of this. But you can see it's a very, very effective effect. I definitely recommend having a go at it. Maybe we'll do a stream at some point where we try and implement something like this. I'm not sure when, but we can maybe do that. Regarding the Flimbird's quest music, there's a comparison of the title track on YouTube between 8580 and 651, and then in the comments and for your information, it should be played on a 6581. Okay, yeah. I would agree. I think it sounds a lot better on the 6581. Yeah, and there really is, Stoker's right, there is so much stuff out there to learn from. I'm always finding new things to try and to learn. No, they're not actually moving the charts in memory. So if you look, if I just hover over that character there, you'll see that all that character is doing is this block is just being shifted. That's all that's happening. They're not doing any scrolling. This is just another character set. So every horizontal strip of characters will have a space on either side, or a shared space, like so, that they can scroll into. But yeah, they're not actually shifting them in memory. They're just changing the pointer. And there isn't, you'll notice other than that, there is no other, why can't I make, oh, because I'm dead, okay. I'm drawing all over the screen there. Other than that, there's no character scrolling going on. That's just literally just character set changes. And this character here is, the reason this looks weird is because when you're in the upper character set, there you go, this is actually pointing to all the raster interrupts and stuff. The very last character in the top Vic bank you can't really use, which is problematic for some things, but for this it's absolutely fine. But yeah, so it's a beautiful effect. It is just very expensive and tricky to get right as well. I mean, it takes a little bit of time. So, but yeah, maybe I'll do one at some point. And explain it. There is a version of Charpad out there. I think somebody mentioned it today on Discord. I think it was James actually. That there is a version of Charpad out there designed for making those char sets with shifts in. Okay, so let's have a go at making this effect. So let's start a new file. Let's call it. I'll just call it start.asm. It's the easiest way to start these things. Let's start with our usual basic upstart to point to entry. This will be our main block of code, and then we'll import some stuff in. So we'll import the screen to, where can we import this? Let's import it to 4000. Let's do all our work in this second Vic bank here. So import binary, and we want screen.bin. So, and we'll put our character set at 4800. Import binary chars.bin. Right. I'm gonna do my usual setup, so I'm going to disable the interrupts, which I will then clear at some point. And this is my infinite loop, so I'll just call it loop. Actually make a jump loop. So once I've set everything up, it's just going to jump to this loop. Then I'm going to do, I'm going to disable the timers, the CIA timers, because we are going to use a raster interrupt shortly. I'm not going to use it right now, but I'm going to disable them here. I'll set the background to black, set the border to black as well. I'm going to disable kernel and basic because I don't need them. I just almost always do this straight away. Then we need to set these values up. So I use this memory map. Let me find it. This is the memory map I almost always use. Whoa, that's bright. This screen is insanely bright. It makes me glow on camera. So we need two things. We need to set the bank up first, which we do at DD00, which is here. So we want this bank here. So we need to set the bottom 2 bits, the lowest 2 bits of DD0 to 10. So you can do this by loading in those values. Keep the top 6 bits and turn on the lowest bits as we want them, which is like that. So that sets the bank up. Let's label that Vic bank, screen, char pointer, and now we need to point to 4000 for the screen, 4800 for the characters. Again, go back to the memory map again. This should be D018, I believe it is. So we want bits 1 and 3 to be 0, 1 to 3 to be 0. No, sorry, to be 001. So 001. That's bits 1 to 3, so we need a 0 on the end. and then the top 4 bits point to the screen RAM. The screen RAM needs to be at 0 here, because the banks are in banks of 16K, so this is the offset from the beginning of your bank. So we need the top ones to be zeros here, and that should be 3, 4. There we go. And I've lost all my OBS. Where's it gone? There it is. Cheap stream lighting. Just have that window on screen. Yeah. Dr. Me. Yeah, it was faulty. I've changed that now. Glow is very nice. Yeah, this. So I've got a new HDR screen, which is really nice when you're gaming. But unfortunately, if you put anything white on the screen, it kind of glows insanely bright. So shell and glow. Yeah. There we go. Right.
2, 3. Outrun.
Thank you for the bit, Citizen. Welcome to the stream if you just joined. Challenge Shimmer. That should be. I need to start making my own things. I mean, my cat probably. Actually, my cat does like hugs, but I'm not gonna copy Hayes. I'll do my own. But maybe one of them can be. I'll give you a shimmer for 3,000 or something. I don't know. I'm too late. I'm really lazy with stream stuff. I don't spend enough time to do these things. I'm always doing other games and things. So. Okay, so alone this should be enough to actually display something on the screen. So let's give it a try. Just make sure it actually works. No, there we go. We do have a problem in our char set and the map because we're using this byte. This was the error that it threw. So our map actually has 320 characters in. It should only have 256, like so. And that's why we're seeing that error, because this character was outside the bound. So I'm just going to fill that with that character. There we go. Re-export the map. That's all I need to export here. Actually, I'll export both. I'll export the screen. I will export the character set as well, so it's got less characters in it. Don't copy Hayes, but make Cat Hug redeemable. 2,500 do a shot. Can you imagine that? That would not end well for me. Many of you have seen what happens to me when I start drinking shots and tequila. It's not a pretty sight. Okay, let's turn multicolor mode on because it's obviously in single color mode. So multicolor mode is D016. Thanks for the follow, Brody Man. Welcome to the stream. D016, and we need to turn bit 4 on. Okay, so load D016, and we just need to turn on that bit. We can just use OR because we don't need to. We don't need to change anything else. The reason we used AND here first is because we wanted to clear these just in case that was what was set. We need to make sure we clear those 2 bits before we set them. Here we're only setting 1 bit and we definitely want it on, so OR should be enough. So that should give us the multicolor mode. Turn this chart shift off, there we go. And then we'll set the colors and then we'll start scrolling things. Oh god, look at those colors, they're awful. Right, okay, so we've got a multicolor mode, a character color mode, which is this blue here. So what have I got in my map? I've got yellow. So let's start by filling the map with yellow. So set colors. So set colors, nice and simple. We'll just do a loop. We'll start with X at 0. We want yellow, but we need it to be multicolor, so we have to add 8 to it. So it's actually, yellow is 7, we add 8, so it becomes 0F. And that will give us yellow in the foreground color. And then we store those at these locations. Now you can just do 250 writes to each section, but to be honest with you, it doesn't make much difference if you do it like this. I can do increase X, fine, doesn't really matter which way we do it here. So this should give us yellow in the middle here instead of blue. There we go. Now we need to change the red and the white. So the white is actually that colour there, which is dark grey, which is 11. I'm bound to get these the wrong way around, so let's set them both and see if I've got them the right way around. I bet I've not. Actually I did, fair enough. Cool, so we've got our map in place. So we'll start by setting up basic scrollers for these things. Now I'm not going to go into making optimized scroller, I'm just going to use unrolled loops. So if you're unfamiliar with unrolled loops, I'll explain them a little bit as we go along. Kicksemmel makes them really simple. So if we look at the map, we need to scroll, let's turn the grid on. We need to scroll these individually, so I'm going to make 4 routines here. One that's going to scroll the big ones, one that scrolls the second largest, then the third largest, and then the tiny ones. And then what I'll do when we've done the tiny ones, I'm going to show you how we can do these just by using char shifting, because while we can scroll these using a split, it's going to be a bit cheaper if we just do it with char shifting. You could char shift everything here, but it would start getting expensive for these big things. But for something like that, when there's just 2 characters, you may as well just use a char shift. So we'll start by scrolling the outer ones first. So let's make a routine here. Let's call it scroll layer 1. And basically what we need to do is we need to create a loop which is going to go through each column in here and scroll it over by 1. So there's 40 columns on the screen, so we're going to go, if you're used to JavaScript, this is really simple because this is just JavaScript basically. Actually we'll scroll from here like so. Is that right? Yes. And we're going to take screen RAM, which is here. So let's make a label up here. Let's call it screen RAM. I'll just call it screen. Just makes it easier to read. We're going to load the value in screen. I'm not going to do 2 loops. I'm just going to do it as repeated statements. So we'll do plus our row number, which in this case is 0, plus I. So loading the value that's in this location, which is our screen RAM plus 1, and we're going to store it at screen plus 0 plus I minus 1. So we're going to shift it backwards, and then I'm just going to copy that. So we're going to do, actually this should be, sorry, times 40. It's 40 characters on each row, so I like to put the zeros in, even though 0 times 40 is 0, I like to put them in just because it makes it a bit easier to read and see what's going on. So if I run that now, what that's going to do is it's going to shift everything across by 1, but what it's not going to do is it's not going to fill in the characters on the other side. So what I need to do is I also need to grab that first column and store it at the end as well. So the way I'm going to do this is at the very beginning here, same as we did before. I'm just going to load a different register. Is this the easiest way of doing it? Yeah, actually this is fine. I know, because this is going to go, hang on, this is going to go all the way across the screen. We maybe should be going down instead. Load that value, put it on at the end. Just trying to think of a sneaky way of doing this. Trying to be clever here. So the thing with unrolling loops is you can get a bit cocky sometimes. And yeah, I will be using hardware scrolling. So, but first we're just gonna scroll the individual pieces, so we know how to move one piece, and then we'll make raster splits and actually update them at different times. I'm just trying to think the simplest way to do this now. Actually, I'm going to do this as separate loops instead. So I'm going to do one loop for each one. So at the very beginning here, I'm going to we're loading the value that's being copied into here, and then we'll store that at screen. So that'd be it loops round basically, and then actually we can put this in another loop. So this is just scrolling one line. So if I show you that, let's just do it in here. It's going to run really quickly. So yeah, so let's just put a little delay in here. So let's load D012. Sorry, it should be the other way around. We'll change this for a proper raster interrupt in a minute, but for now let's just do something simple like this. So we just got one line moving along like that. So now if we make a loop for that, indent all of this. We need to do 4 lines, so we'll do like this. And now we can replace all those zeros with J's. So what this is doing is it looks kind of like JavaScript, but at assemble time what it actually does is it unrolls this all. I'll show you in memory what this looks like. You're not using JavaScript and you don't need 38 columns. Yeah, that's a good point actually. This we can probably reduce this even more, but I'm just going to do 40 columns for now. It's simple because we're just going to loop things around, but we will be switching it into 38 column mode in a minute. So there we go, we've got the top one moving. So now we need to do the same for the bottom one. We can basically just copy this loop because this loop is absolutely fine. We just need to change the row numbers here. So these row numbers, so 25 and 21, like so. So there we go. We've got the outer ones doing. So quite a simple routine. This is taking up a lot of memory. It's not very efficient, but it's going to do for what I want to do. I don't want to spend time wasting time doing kind of very optimal scrolling code when I've got loads of memory. So what was the highest CPU speed of the Amiga? Yeah, I don't know. But there's plenty of people here who do, so as I think you're finding out now through Acmafin. So now we need to scroll 3 rows. So we start at 4 and less than 7. So this would be less than 21, 18. And I've done that in the wrong one. '18, 21. There we go. So So they're moving at the same speed, that's fine. We're going to change that shortly. Just need to get everything moving first. We'll scroll layer 3. And this is 2 layers, so we're going to go from 7 to 9. And from 16 to 18 down here. What is that tune? Hang on a spring. Something seems a bit off there. Or is it just the way it's... I think it's just the way it's... Ah, it's fine. Okay. And finally we do the other layer, which is just one line. So we don't actually need the loop here. And I'm going to change how this function works anyway, once we get the rest of the hardware scrolling in. So we don't need the loop here. The value is just 9. 9, 9, 9, 9. I mean, you could keep the loop in, but it would be a loop of 1, which is kind of pointless. And this is it 16? 16, 15. We'll find out in a minute if this has worked. Get rid of that loop. Cool, there we go. So I mean, it's moving very, 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 very quickly, because we're moving an entire character at a time. Now, you could do it without hardware scrolling. If you wanted to make it really fast, so you'd move the first layer 4 times, second layer 3 times, and so on. But this is likely to be a bit too much for 1 frame. We might get some tearing. Well, we're not getting tearing, but it is kind of working. But you can see it's way too fast, so you have to slow it right down to see the effect. And it's nowhere near. We are getting tearing. There you go. You can see it here. And it's nowhere near as quick as we would want it to be. So let's not do it that way. Let's start looking at hardware scrolling. So set the maximum speed back to 100 again. Let's change these back. Okay, so we've got a way to scroll each layer, but we don't want to scroll them straight away. So what we're going to do instead is we're going to keep a scroll value for each one. So we'll create some variables here. We'll call it layer scroll values, I guess. And in here we'll start everything on 7. Now the scroll values go from 0 to 7, and actually I can never remember which way they go. I think 7. Hang on, let me try it by loading it up. I always struggle with this. Never remember which way the scroll goes. Horizontal raster scroll. These are on 6. So 53270, and the default is C8. So if I put 200 into 53270, I need to turn my joystick off because it's stopping me from pressing E. And if I increase that value, yeah, so going from 7 to 0, we'll scroll it from right to left, which is what we want to do. We're going to scroll everything from right to left. So we'll have a function here, we'll call it update scrolls, and we'll have layer scroll speeds here. So layer scroll speeds is going to be how quickly each layer scrolls, with the outer layer being the fastest and the inner layer being the slowest. Okay. So instead of scrolling everything there, we're going to scroll things in here, but we're going to do it depending on these values. So we're going to call this update scrolls. And for now, we're just going to change this value. We're not going to set it anywhere. We're just going to change this value. So we'll loop through the values. We'll go backwards through the loop because that's the sensible way to do it. So you start at the end, you decrease the value, and while the value is still positive, you repeat the loop. Then in here, we will load our layer scroll value, comma X. We'll set the carry bit, and we'll subtract layer scroll speeds, comma X. And if the carry is set, then we don't need to do anything. We'll call this loop so we can come back. If the carry is set, then we haven't gone below 0, so we can just jump straight to here. However, if the carry is set, then we need to do something else. So the first thing we're going to do is we're going to add 8 back on, which is going to wrap our value background. The carry is clear because this, so that's absolutely fine. So this is just going to keep looping our value from 7 to 0. But we're also going to do something different here as well. So update scroll layer. So these things here. I'll show you how we'll do that in a second. And then the final thing we do is we store that value back in the layer scroll, like so. Okay, so the way I'm going to do the layer scroll, let me think. Jump tables. Actually, we've not done jump tables, I don't think. So let's do a jump table. So a jump table is basically a list of values that we can jump to using a special addressing mode of the jump instruction, which is called indirect jump, basically. So what we're going to do, first of all, we're going to call a routine, which I'm going to keep in here, which is our jump routine. And that's going to be here, so we'll return from the subroutine here. So this is our jump routine. And the jump routine's job is going to be, first of all, I need to make sure I'm not using X in here anywhere, which I'm not, because we need to keep X. X is what our loop is. So the jump routine is basically going to take our X register, it's going to transfer it to the accumulator, and then it's going to shift it to the left. Shifting it to the left is going to double it. So instead of 0, 1, 2, 3, we're going to have 0, 2, 4, 6. And then if we align this with 100, like so, we can simply do jump table, like so. And the only thing we need to do here is jump self mod. So this is, we've not done this before, but this is kind of, okay, so let me explain what's going on here. So when we call this jump to subroutine, it's going to come to here, and it's going to stay here until it hits an RTS. Now the RTSs are in here, so all we need to do is we need to jump to the right one of these, and then when it returns it will come back to here again. Now to work out which one to jump to, we need to basically get our index here, times it by 2, and store it in the lower nibble of this. So if you imagine the jump table is at 7,000, we need to change that value, which is what this is doing here. So this is changing this value to either 0, 0, 0, 2, 0, 4 or 0, 6. And in those locations we have these words which describe these addresses here. So it's now going to jump to the correct scroll to do this. So if we run this now, what we should see is it still won't be hardware scrolling, but we should see things you should see things moving at different speeds. Actually, we've got the inner one moving faster than the outer one. Done that the wrong way around. Yeah, it should be the inner one moving slower, which is fine. We can just change these values. Can use zero page indexing rather than self mod. Why is that moving at different speed? What the hell? What have I done wrong there? I don't think there is a zero page. Let me check. I'm pretty sure there's not a zero page indirect addressing for that. Not on there. I might be wrong, but I don't think there is. Jump. No, there isn't. So you've only got absolute and indirect. So zero page isn't really going to help there. Oh, what is that tune? I recognise Monty on the Run. I thought I recognised that. Yeah, it does annoy me you can't use it for jump subroutine as well. It is really frustrating. Yeah, I mean, I mean another way you could do it as well is you could push these values onto the stack, and then do an RTS. And it will jump to this location, but I mean, this is probably a slightly safer way of doing it, rather than messing around with the stack. But you could use the stack to do the same thing. But this is fine. So this is updating our scroll layer. Oh, we need to store the value before we jump to this routine. So I'm actually going to store this here. And then again here, if it needs to add the value, it can store it there, and that way it's gonna. That's probably why it was scrolling at the wrong speeds. Yeah, we're gonna write to the hardware scroll register in a minute. The stack is from 0100 to 01FF in memory, so 256. But to be honest, most people won't probably take it more than about 30 or 40 high. And so it's kind of handy to know that and know where your stack is, so you can actually use that extra memory at the bottom. You'll see a lot of games use that. A lot of unpackers use that area as well because it's rarely used for the initial kind of boot of a game. So let's reverse these speeds again. I need to work out why my speeds aren't working first. The outer one should be moving very, very slowly, and it's not doing. Once we get that right, then there we go, that's better. Right, so now all we need to do is we need to apply hardware scrolling. So at the moment this is just scrolling everything, and it's only scrolling the screen across when that scroll value drops down by 1. So the next job is to set up some raster splits to do this for us. I'll keep it all in one file. It's probably a little bit messy, but let's do it all in one file. So we'll create a function called setupIRQ, which we'll call first, and then this will have different split for each area. Fast sorting. Yeah. Hi, Parallax Digital. Welcome to the stream, dude. Yeah, multiplexers do tend to use the stack, and they also use a lot of zero-page stuff as well. So you'll often find, especially in games with very, very large multiplexers, like Armalite probably does it because it's got 30-odd sprites on the screen at once. That they store all the sprite data in zero-page because you need to be able to access it fast, especially when you want to sort it. You definitely need to be able to access it fast. Because as anybody who's done computer science knows, sort routines can be notoriously expensive to do. Okay, so yeah, let's set up our interrupts. So we need to set the interrupts before we clear the flag, which was here somewhere. So we'll move that clear down a bit. Actually, let's move it to after we've set all the colors and everything. So just before the loop. and we'll set up IRQs here. In this function, so first of all we need to turn on the IRQs, which is storing that in D01A. I need to double check that. Pretty sure it's D01A. D01A, raster interrupt enabled, yes, there we go. We're not using the kernel, so we can just store our interrupt vectors in the high vectors, the hardware vectors in RAM, which is at these locations. And let's do this. No, let's just do it manually. I don't want to spend too much time writing super efficient code, so let's just do it like this. And then we need to pick a line number. So our first interrupt vector, we may as well just stick at the very top of the screen. So we'll do it at 0. I guess we'll store that at D012. And the other thing we need to make sure is that we're not using the high byte of D011. D011 is actually bit 9 of our raster line. There we go. So this is going to set up. There we go. This is going to set up our IRQ. We're going to create a little macro here called store state. This is just going to push the accumulator onto the stack. Transfer X to the accumulator, push that onto the stack. Transfer Y to the accumulator, push that onto the stack. And we'll do the reverse here. Now, if you're using the kernel, you can just exit a routine by jump to subroutine EA31, and that will do this for you, so you don't need to worry about this. But if you turn the kernel off, you actually do need to store these values, because if you change any of them, then you'll get all sorts of weird issues. So I like to create 2 macros like that. Just stick them right down the bottom there, out of the way, so you can't see them. Okay, so we need to create our first IRQ. So this is for our top area of the screen. So the first thing it needs to do is store the state. I've been told you don't need to do this, put the colon at the beginning anymore, but I like to do it anyway, just so it's obvious when I look at it that it's a macro. I'm sure it's obvious to other people as well. There we go, restore the state, return for the interrupt. Now, before we restore the state, we also need to acknowledge the interrupt by shifting that value. And then before that, we need to set up the next interrupt. So for now, I'm just going to make it set the same interrupt again. And we'll copy paste this block of code around as we do each part. So for now it's just going to point straight back to here again, so it's just going to loop this code. We can test that by just putting an increment in the border color here, and what we should see is the screen flash, and you probably won't see the entry point for it because it's going to be full of type. In fact, it's not doing anything. Why is that not doing anything? Okay, let's see what's going on there. Running the debugger. Why is that not doing anything? Oh, because I need to actually acknowledge the interrupt here as well, or else it won't start, that's why. It's still any... Oh, what is it doing? It's doing strange stuff. Okay, let's have a look at this. So, set up IRQ. See if anybody's reminding me of something that I've missed here. Don't forget to change the high byte of the IRQ vector. Oh, thank you. I don't know if that's what you were pointing at, but yep, I was pointing to the wrong thing, so I need to change that here as well. I was putting the low nibble in twice. I'm surprised that even worked, to be honest, and didn't crash. So there we go. You can just about see it's activating on line 0 at the top, so that's fine. That's what we want. And so this is our first. So there's 8 sections to this scroll. So we'll start with the very top piece. and the top piece, the hardware scroll, is this value here. And why does it scroll? Oh, because I need to close this. So if you're in Sublime and you're using an unregistered copy and you struggle to scroll, it's because of this pop-up. If you close this pop-up, it scrolls perfectly. I don't know why it's like that. I suppose it's just another way of nagging you slightly. But I'm a cheapskate, I'm not going to buy it. Yes, thank you, Andy. Right. Bit more Sprite. I really should get product placement money for that. I drink enough of it on stream. Sprite 0 though as well, so it doesn't rot my teeth. It just rots everything else. Okay, so we need to load the hardware vector. Okay, so what we want to do is D016, it's this one here. We definitely want multicolor mode on. We definitely want screen width of 38 columns. So we need to set bit 3 to 0, bit 4 to 1, and basically whatever this raster scroll is. So the way we can do that is we was it that? I've already forgot. I've only just looked at it. Yeah, okay. Yep, like that. And we can all that with layer scroll values. We'll use post, don't need to use any indexing here. And we'll store that at D016. And that should scroll, in fact this is going to scroll the whole screen. So it's going to look a bit odd. So let's just run it. I'll show you what I mean. Only the top section will look correct, and maybe the bottom section as well. But everything else will jitter. So you can see the bottom and the top look fine, but the middle's jitter, and that's because the scroll values are wrong at those points. But we've got the kind of basics going here now. So basically we need to do the same for the next line as well. So there's a lot of code duplication here. If you were to spend a bit of time doing this, you would make this a bit more efficient. You'd probably store these vectors in a always make it point back to the first one for now. You would store these in a table somewhere. You would store the lines in a table somewhere. But we're in a bit of a rush, so we're going to do it this way. So we're looking at round about line, I would say 5.2. So let's set 5.2 here, and we need to set the scroll values to scroll values +1 because it's the next layer. Let's try and do them all and see how close we get. Let's just do the top half first. So I think this is going to be, well, it's going to be another 18 on top of that, so it's going to be 6. What was the last one? 5.2. So this would be 6A. And this would be layer scroll 2. So hardware modifier. You only get sponsorship for Sprite, so it's better. Sprite Sarah. Oh dear. Yeah, I talk about sprites on stream. I drink Sprite on stream. I should definitely get some kind of sponsorship deal. God damn them. What am I looking at? Wrong thing. Okay, this is what I wanted. And I'm going to add another 2 onto this one. 2 lines. So this would be 6A, 7A. And this would be IRQ4. We'll do that. We'll just make it jump back to IRQ1 at this point. Just to see if we've got the top half correct. We should have it correct now, I think. Oh, because I didn't call it IRQ4. There we go. Okay, so there's a little bit of line jitter in here, and this section here isn't actually scrolling. Why is that not scrolling? I actually applied the hardware scroll there. So this is just because our rasters aren't stable at this point. So we can do this by, if we go to the line before. So we start with this one here. So this goes to line 52. So we do it the line before, and then at this point here, compare D012. So this is now going to wait for the next line. That should get rid of one jitter. Which it kind of has. I mean, it is still a little bit over there, but it's not too bad. I'm not gonna fuss too much, but I will add it into the other areas as well. So again, take one off here. Add the little jitter correction in here. I'm not sure why. Oh, because that should have been 3, not 4. There we go. And take one off there, like so. There we go. Raster Splits are what C64 coders tell you to make you feel bad for not knowing how to code for C64. Source supposed to know why pretending in Raster Split and change their coordinates. Yeah, Booney, that's pretty much it. I actually did consider doing a multiplexer on stream at some point, so I might. I think multiplex is probably going to be of more use than the Flimbo's Quest stuff. The problem with the multiplexer, because if I do a multiplexer, I want to do it from scratch, so you guys can see what goes into making one. So I'd have to kind of prepare a little bit for it. So I'd have to make sure I'll do it myself first. So I need to try and make sure I can do it within 2 or 3 hours. And there's so many ways to optimize them as well. So if I do one, it will be a very basic one, you know, like a 16 or 24 sprite multiplexer that uses general sorting algorithms and doesn't really have many optimizations in it, but good enough to kind of show you the basics of it, and then you can learn a bit more from it. But it's definitely something I've considered doing because I think it would be useful to people. There we go, that'll do. I mean, there is a little bit of a flicker because we've got some line jittering going on. We can probably correct that a little bit just by juggling these lines around a little bit until we get rid of it. So let's try that. Yeah, that's not bad. So we've got a little bit of a delay here. I think that's just because we're doing our shifting of stuff at the wrong time. So I need to figure out where the best place to do that is. We'll change that position shortly, but for now it can kind of stay there. I think we'll probably set another split up. As soon as we've done this one here, we'll probably set another split up which actually does the scroll just down here. So let's go ahead and do the next layer. So we don't need to do another split for this one because it shares with this one. You can see it's moving at the right speed. We do need to move that line up though because it is cutting it off a little bit. So let's move that one up. There. And let's just do the next split. So IRQ 5. I really hate doing it like this. I would much rather this be in a table, but to be honest, the amount of time it's going to take to do that, and I've only got like an hour left, and I really want to show how to do this plus character scrolling as well. So, but I will share all this code afterwards if you want to kind of refactor it into nice neat tables and code that's not unrolled. Because I mean, if you look at the code already, it's like filling up loads. We've wasted 3K or so on code. And we're only really scrolling like a demo effect. We're not doing anything particularly special. Okay, so our last split was here. We need to add 3, 6, 7 lines on. So that's 3, 8 onto whatever the last one was. 7, 9. Wait. Yeah, 3, 8 onto that, so that becomes a B1, I think, if I'm calculating that right in my head. We'll just point that back to 0 for now. Right, let's see if that starts scrolling it. That is scrolling. I'm going to move that line down a little bit. It's a bit too much. What's the raster time of that effect? I will demonstrate that raster time very, very shortly. You're amused at how many people are watching this. It's the 64, man. It's amazing. Amiga Bill. Thank you for the raid, Amiga Bill. And welcome everybody that's coming along with Amiga Bill tonight. Hi, guys. Thank you for the follow, Exploding Fists. And thank you for the raid, Amiga Bill. Yeah, we're just in the process of demonstrating some parallax effects and how to implement them on the C64. We've had a look at a couple of games, and we're just going to try and implement what we've seen in there. Well, in two out of the three games that we looked at. So for those who don't know, I'm Shannon50k. I do C64 coding. On Saturdays I do game development, which is a collaborative effort with everybody on Twitch and on Twitter. We're working on a single screen platform game. Right, keep quiet about you know what. Oh yeah, I'd forgotten all about that, Andy, and now you've reminded me. Yeah, and on Thursdays like tonight I do Dissect streams, so we look at other games, how they did certain effects, and we're starting to kind of dig into the technical details on those and do them. We Amigans are keeping up with the Commodore. Yes, you are indeed. Have I looked at the Commander X16? I've had to look at it a little bit, but to be honest with you, it's too much for me. It's more of a 16-bit machine than anything else. I don't like all that power. I like the limitations. I do prefer the kind of hard limitations of the Commodore 64. So thank you for the follows, guys. I missed those two were Benabite, and I didn't see the last one. Let me check who that was. I cannot see who the last one was. I'm not keeping up. I'm keeping up with the Commodore, but I'm not keeping up with the stream details. So apologies if I've missed your follow there. Thank you very much. Okay, let's carry on with this. So we just need to move that line down a little bit. So we're currently trying to implement a parallax, multi-layered parallax scroll effect using hardware scroll registers to do. Thank you, Fatal Blade, for the follow. Welcome to the stream. What are you guys playing tonight then on Amiga Bill's channel? While I figure out these values. Let's have a look. Two more rows onto that. So B2, C2. Text input was one. Text input? I don't know what you're... Oh, thank you, Colt. Thank you, text input, for the follow. And welcome to the stream, dude. Mr. Covers a ton, nothing wrong with that. Cool. Hand up if you love this tune. What is this tune? I can't see what it is. Construction kit of some kind. Okay. So that's IQ 6, let's do number 7. I think this is the last one. No, there'll be one more after this. So this is not the neatest way of doing these things. There's definitely better ways to do this. But we're just trying to demonstrate that you can make these effects with simple raster code, even if it is kind of repetitive and I'm wasting an awful lot of memory doing this, but it will still work, so that's fine. So this would be DA, and this is our final scroll value here. So once we've done this scroll, the next IRQ is our final one, and we'll do this right at the bottom of the screen. So we do this round about here. We should be able to do all the other scrolls across the scroll of all the update scroll routine that we're currently doing in await. We won't do it in await, we'll do it in this section here. Hopefully this all fits into memory, otherwise we might have to stagger where we do the updates, but also it should be fine. Flood James Pond, I love James Pond. I never played it on the Amiga though, I can't remember where I played it. I think I played it on the C64 a little bit, but I think the one I played the most was probably the Mega Drive version. I really did love it. I loved the fact that the cheat was to go on top of... What's it, James Pond 2? It might have been James Pond 1, but you go on top of a house at the beginning, you collect the objects in the order that spells out cheat. That was really cool. Okay, let's figure this last drop out. Scroll value 0s, IRQ 8. And for now, I'm just going to make IRQ 8 return back to the beginning again. So, okay, that's quite a lot of code without really looking at it, so I don't need that stabilizer there. So let's see. Probably won't work now. No, it's working. There you go. So there's a little bit of flicker. I'm not going to worry too much about that, but the effect is actually working. We're not getting any stutter. The top actually does seem to be stuttering a little bit. But to be honest, am I going to worry about that? No, I'm not going to worry about that. I'm not. What I'm going to do, I'm going to move our update function. So currently we've got our update in here. Sorry, here. I'm going to get rid of this. And instead I'm going to stick it in our IRQ at the bottom here. It might smooth it out. It might not, but it might smooth it out. Is that an Aperture Science logo on your PC? It is indeed, yeah. It's all Portal themed, so it's orange and blue fluid. I've got little portal guys here. I don't know if you can see it. I can't get that close, but yeah, you can see I've got little orange and blue portal guy. It's kind of hard to see, but there is an Aperture site. There's a Portal kind of test room logo in the back, and all the lights kind of light up purple, orange and blue as well. Oh, does Hayes play Cockatony Wolf or whatever it is again? Cockatony Wolf. I forget the name of it. Actually, that update scroll did not work there, did it? At all. Interesting. Let's try it there. Oh, it did not work there either. Okay. That actually worked better where it was, didn't it? So, do you know what? It's because so that will, let's do it in like 5 or something. Smooth the lines down a little bit, and let's restore this back again here. Probably don't need this extra bit here, but I'm going to do it anyway. It doesn't really matter if this doesn't work, I can put it back. No, it definitely works better when it's not in that loop, so... Okay, fine, remove it from that loop. No idea why that works better there, but it does for some reason. I'm not going to waste too much time on it, so... Okay, so... It's taken a little while, but you can see that's how we get the parallax working, just by using horizontal scroll registers. Obviously you do a bit of tidying up to get rid of the unstable rasters. You would stabilize them a little bit better, maybe using the stabilize routine I showed you guys when we did the VSP scrolling, or just kind of some clever timing with those weights. I mean, you could probably fix some of these with just by moving the line number. So like for instance this one here, let's try moving the line number for that one. So that's the second to last one, and that's the only one I'm going to mess with. So it's not this one, it's this one. If I just move that up one line, it'd probably get rid of some of the flicker there. Yeah, there you go. It's kind of got rid of it. So there's a little bit going on, but it's much better. What I'm going to do, I'm going to take a quick 2 or 3 minute break. I need to get some more drink. Have a cigarette, and when I come back we will add an extra layer in the middle, which we can't just scroll. Well, we will scroll it using the hardware scroll, but it's not going to be able to do the parallax behind it without using characters. So I'll take 2 or 3 minutes, guys. I'll be right back, and we'll put that final bit in. Alright, be right back, guys. And I'm back, guys. Getting dizzy with the be right back effect. I didn't show the rip in the graphics. Yeah, I can show you that. It's pretty easy to do. So this is the charpad. Let me open another copy of charpad though. So if you go into Vice, well, I'll show you from here, but let's, oh no, actually let's do it from the actual demo that I got it from. Just get to the point that you want to rip the graphics from. I could bring another sprite as well. One Man and His Droid, great tune. Although I know this more as the Invader Load tune than anything else. Let's just accelerate this a little bit, it's a bit slow. So these are the characters that I stole. Same effect, we're just recreating it. Obviously they've spent a bit more time to stabilize the effect as well, and they're only doing it on one half, so it's half as much effort to scroll the screen for this. And then you just take a snapshot, save a snapshot image. I'll put it on my desktop. I think I've already got one actually, but I'll overwrite it anyway. You will get an error sometimes, and Vice will crash, but it has still worked. And if you go to import Vice snapshot, you get this little window, and in here you can cycle through the character effect, the character set. So you open your snapshot, and you can see the character set up here as you scroll through. So I basically scrolled through until I found the effect I wanted, the character set I wanted, which is here, and then I looked for the screen until I found it, like so. There you go. Click OK, and there you go. You've got the character set. Delete the bits you don't want. So I hate the fact that delete actually removes those. And then you can clear this up quite quickly using the fill tool and the paint tool, like that. There you go. And there was my initial screen. Turn multicolor mode on. Set the char color to an upper. So if you want multicolor, you have to pick a bottom row character, hit color here. There you go. Set your colors to the things that you want. So I went for yellow, grey, and grey, like so. I got it the wrong way around, and that was it pretty much. And then all I did was I took this character set, pasted it here, and then if you use this flip tool, you can turn all those characters upside down. And then I painstakingly redrew this up here, upside down, and then exported it to give me this, basically. It's that simple. It's that simple. Hi, Still a Car. Welcome to the stream. Did you arrive in time for Masters of the Universe? No. So I've got a different Sid playlist now. I'm going to see how well this one does. I keep getting copyright strikes on YouTube for the other one, so I thought I'd try this one. And there's a little video just there to show you what's actually playing. Cool. Right. Let's. Hi, Prince Phase. Welcome to the stream. It does look like a Space Harrier level, doesn't it? But what I'm going to do, first of all, I'm going to just show the raster time. So the raster times for these are going to be really quick because they're just setting these values. So I'm not going to show you this bit. Thank you for the follow, Elgit79. Welcome to the stream. What I'm going to do is I'm going to just put around this bit here. So I'm just going to increment the border color here and decrease it here, and we'll have a look at how much raster time we're using. How much frame time we're using. It's not really raster time. So you can see that's the update starts here, and the worst is it finishes here, which is pretty good, to be honest. So what we're going to do, I'm going to load in the other character set that I've got, and I'm going to show you how we're going to make that work as well. So let's load that one. Let's close this one. So I did two character sets, pretty much the same, but this second one has one ever so slight difference. I'm going to put that in the right place. It's in the wrong place. Put it there. There we go. So I'll export that, and we're going to make this move. Now what we're going to try and do is we're going to make the C64-bit move. Thank you for the follow, Stiller Carl. Yeah, it is very fudged when it comes to copyrights. It's always Alistair Brimble as well. It's always Alistair Brimble. Now I don't know if it's him directly or if it's some kind of agency or something that owns the rights to his music, but it's always his tunes that cause problems, and it seems to be a lot of tunes as well. So let's export this. What we're going to try and do, this is going to scroll like normal. That's not going to change, but now we're going to have this section in the middle. At the moment it's static, but what we're going to try and do is we're going to try and scroll the C64 through, but these are going to be holes. And we're going to try and we'll start by just kind of messing around with this character here and seeing if we can keep it static, still on the screen. Then we'll try changing the speed of it and stuff. So it has been selling its stuff. Okay. Hi Foray, welcome to the stream. Okay, so let's export those files. Put my phone back on charge. Export map. So we're going to export the screen again, same as before, and we're going to export the binary, same as before. Export character set. That's the one. It's not binary, character set. Sorry. So you can see what's happening here now. So the middle section is no longer kind of following along with these here. There's a bit of a disconnect now between what we're seeing on the outer sections and what we're seeing on this section here. And the reason for that is because while this is actually hardware scrolling, this middle portion is not being shifted along. So we need to shift this along at the same speed as this. So let's start by doing that. Actually, is this going to work with color? Because we might have to do a color scroll in the middle as well. But that's fine. That's fine. We can do that. So let's create a scroll layer 5. We only need one section of this. So we don't need this bit here. We just need to do the middle section. And the middle section goes from actually, is that right? No, it needs to be one of these sections like this. And that goes from 10 to 14. Okay, so it's 10, 15 here. Cool. Oh, I'm in the wrong bloody place again, haven't I? There we go. 10, 15. This is layer 5, so we can actually do this all in one go. So let's just add it to this section here. So we'll make this scroll layer 4. Scroll layer 4 is our very outer section, and we'll make it include those bits there. So we get 9 and 16. So we should get the same thing going on. But now that middle section should move as well. So cool, we have a section moving in the middle now as well. I'm going to get rid of that raster because it's making my the debug border thing, it's making my eyes hurt. There we go. So I've made one small change, is I filled this area in just above these so that it looks connected to this section. But now what we want to do is we want to move this character in a different direction. So first of all, we're going to have to do a color shift on these 3 rows because the colors here are going to be multicolor and we need these to be not multicolor. So I'm going to do that first of all by just setting the colours in that area. So I'm going to stop it scrolling that area first. So if I just put a scroll speed of 0 in there, it should stop it scrolling, just so I can keep the characters in place, just to make sure that the colours are correct, and then we'll add colour scroll into there as well. Okay, so we need to colour this area now. So the way I'm going to do that, we've got the whole screen coloured here, then we're just going to do an extra little 3 rows, so we need to do 120 characters. And we're going to load the value at screen plus whatever row that is. I think it's row 11. Plus 11 times 40, comma x. And if it is, let's have a look at our character set. If it is more than 131, then we're going to colour it differently. So we can just compare it to 255, which is the character that it is. So it's not equal, we'll jump to there, we'll call this loop. So it's not equal to 255, we don't do anything. Otherwise what we do is we load 6 actually, we want a blue colour. By using a value less than 8, we're going to force it into high res mode for that area. We're going to store that at D800, like so. So now we're colouring that C64 in the middle. There we go. Do I use counters for the animation? Do you use counters to do the animation? What do you mean counters? So I have these values here, which are our hardware scroll values. The hardware scroll goes from 0 to 7. This is the speed that value decreases. Whenever this wraps, whenever the carry flag is set, i.e. this drops below 0, then we scroll the entire screen for that section over by 1. So you'll see what happens now if I scroll that, because it's got 2 different colours in that section. If we don't scroll colour ramp, we're going to get weird. There you go, you can see it. So the colours, the screen is scrolling, but the colours aren't scrolling. So we need to add into our layer 4, scroll layer 4 into this layer. We need another little routine to just scroll the colour ram across. This we can do pretty much in the same way that we've done this, but now we're only interested in the middle 3. So we've got, we've got here, we've got 7. So if I do, is it the middle 3? Hang on. Yeah, and there's 2 on the outside. So I need to add 2 to here, take 2 off here, and this needs to be the 800. And there we go, we've got colour ram scrolling with it now as well. So the final thing is, this doesn't look like a hole, it just looks like blue paint at the moment, right? So Revision last year was great on Twitch. Yeah, I watched Revision for the first time last year. I was really interested in the shader showdowns, actually. Something I would really want to look into, because I do like messing with shaders. So yeah, it was kind of cool. It's interesting you can combine assembly with high-level languages. Yeah, you can. You can use these high-level kind of constructs to simplify repetitive code. So this is just like an assembly time directive. Basically, anything with a dot like this is an assembly time directive. Tells it to repeat this block of code and insert it this many times. So this allows me to kind of unroll the loop without actually manually having to do it. It's a nice feature. It's in most assemblers, but I prefer Kick Assembler. you know, people are each to their own. There's a lot of people that use Acme and a lot of people use TAS as well. So it's just I prefer Kick Assembler. It's what I've been using for 3 years, and I'll keep on using it because it's great. Okay, so the final thing we're going to do in this layer as well is actually no, we're not going to do it in this layer. We're going to do it in, let's have a think. Every time this moves by 1, we want to move the character back. So we'll do it in our update scrolls here because it's going to move by 1 every frame. Thank you, Arananet, and welcome to the stream. Saying content restricted for you on the stream. I can't see anything. I couldn't tell you why that's happening. Unfortunately, try refreshing the stream, Whitey. I'm not sure why that's happening. So in our update scrolls here, so just before we exit this, we're going to now do character-based parallax here. So as I said, we've got this routine in here which will shift things to the left and to the right. Now we want to shift things to the right, so I'm just going to copy this routine and I'll explain it again as I put it in. So what we want to do is we want to take the contents of that character. So that character is the very last character in our character set, and our character set is at 4800. So that character begins at 4FF8. That is where that character lives in memory, and it fills up 8 bytes there. So the first thing we do is we set a loop up to loop through all of those bytes in that character, and for each byte we shift it to the right by 1. Then if the carry flag is set, that means the very bit 0 has been knocked off the end and it was a 1. If it was a 1, then we need to add it back onto the other end. So we do that by ORing with 80, and we just repeat that once for each byte in the character. So that's 8 times. And that should make that character static as we move. But it's actually cleared it. It has made it static, but it's cleared it with the wrong thing. So let's have a look. What have I done wrong there? Take that value, shift it to the right. The carry's cleared, don't do anything to store it, otherwise back on again. Why has that done that to it then? That's weird. Increase X. Oh, branch plus loop, that should be loop. Let me go and fix that in that file as well. Don't want you guys finding that bug. Yeah, that should be right. Okay, cool. And there we go. We've got a static background in the background there. So because this piece here is moving 1 pixel at a time, in order to move this a little bit less, we would need to do some other trickery here. So one way we can do that is in here. If we just create a scroll toggle or something, doesn't really matter what it's called, and basically every frame I'm gonna increment scroll toggle, I'm gonna load that value in, and I'm gonna AND it with 0, 1. And if it's equal to 0, then I'm going to skip that function. And now this is only going to scroll every other frame. So now it will still scroll with the background, but only every other frame. So we should get a half kind of frame scroll there. And there we go. We've got character-based parallax in the background there. Now we could go the other way as well. We could make the background look different again. So we could, instead of doing this, we could just do this twice. So if I just copied that, I mean, you would do this as a loop really. But now we would be scrolling it twice in one direction. In fact, you wouldn't even do it as a loop, you would do it in a completely different way. Yep, so if you wanted to do it the proper way, instead of doing it like that, you would do this. this bit twice, like so. So now you've got a background moving in the opposite direction to the map. We are starting to get some jitter up here, so I think we're starting to run out of... actually, why are we running out of raster time there? I think we're just hitting a point where it shouldn't be affecting that. That's weird. Maybe this is not being hit at the right point. Let's try changing this value a little bit. Yeah, there's a bit of jitter going on there, but you get the idea. It's kind of working. So I mean, obviously you would play around with timings for things like this just to get the system working correctly and feeling smooth in all cases. It does seem quite jittery at the top though. Couldn't tell you the immediate reason for that. But yeah, I mean, I'm not going to do too much more. I think that's kind of explained most of it. As I say, I don't think we've got time. We certainly haven't got time to do Flimbo's quest style scrolling. That's something I'll have to leave for another day. I think that we can dedicate an entire stream to that, to be honest. Yeah, that's about it. I don't know if there's anything else. If anybody's got any more questions about this before we end the stream, please let me know. I'll try and answer them as best I can. I might just have a go at trying to fix that jitter at the top. It's annoying me a little bit. Why would that be happening? That would be happening because it's drawing too late, maybe. Let's try shifting up even more. Let's try shifting it to the middle somewhere. Oh no, that didn't work at all. Okay. I've never got time for Cockatoni Wolf. Oh no, that's jittering even more. So yeah, you can play around with this value. I mean, normally you would have this update run in an IRQ. You might even want to move from running in a loop like this to actually having each layer update outside of its kind of visual range. So once you start updating the second layer, then you scroll the stuff for the previous layer and so on. There's a lot of optimization you could do in here. This has kind of been thrown together, so yeah, some minor glitches, but it's not too bad. It's about what I wanted to get done for this stream. You can do a lot of variations on this, but this is the basic kind of Moon Patrol kind of scroller, but with multiple layers. Yeah, I mean, you could change this for terrain here, so you can have bushes and trees and things. Like I say, you can add sprites in that move across that fill a bit more of the screen up. And then you could have mountains as the very last layer here. And then up here, this could just be clouds. So you could have different layers of clouds. And it would look kind of nice. It adds a nice kind of 3D depth effect to it. You playing some more? No, I won't play tonight. Left for gameplay? Yeah, sure. So if we look at the routine here, so this is the routine that takes all the time. The IRQs actually don't take that much time because all they're doing is setting these values here. I'm not going to wrap a thing around each one of those, but these are going to all take about one line each, or two at the most. The bulk of the routine is doing the actual scroll. So you can see here we start doing it here, and the worst case scenario is it finishes here, which is probably why this is flickering a little bit actually. Although I don't know why, because it should be... Oh, actually, I bet I can fix that by doing... So in our very last loop, instead of going to 0, we'll go a bit further on. Let's do it around about 30. Yeah, that's smoothed it out. So yeah, we're starting it here. The worst case scenario is when all layers need updating at the same time, so all layers need shifting, and that's when it comes to about here. So we've got probably about I don't know, maybe half a frame is at worst case scenario is what it's using. Best case scenario seems to use almost nothing. So when none of the layers have scrolled past 0, then it's finishing here. But it seems to be kind of averaging around about this position here, with the worst case scenario being here. And to bear in mind as well, we're doing a color copy in the middle. We are scrolling 1, 2, 3, 4 different layers of parallax. If you count the top ones as well, you could say it's 7, but really it's just 4 because they're moving at the same speeds. Yeah, the problem with this though is, in terms of memory, we're using quite a lot. So we're using almost 7K, no, over 7K actually, just over 7K, and that's because of all the unwrapped kind of loops. So you would probably optimize some of these. You would say, okay, it's fairly efficient anyway. Let's reduce some of these loops down a little bit, and you could use 0 page to do that with some indirect indexed addressing, and just unwrap the things that you really need the speed for. So maybe this last one with the color you would leave. Although again, this is only 3 lines, so this could be quite simple. I like the way Flimbo's Quest used sprites to have a static layer on top of the parallax. Yeah. Did it use sprites as well? I don't remember seeing sprites as a static layer on top. Yeah, I'm not sure about that. I don't think they did. But there's, I mean, parallax with sprites as well is another way of doing it. So you can quite easily add to this some large sprites that kind of sit over the front here. So you imagine like a silhouette or something that just fills the entire screen. It's just the same sprite copied all the way down the screen that moves either with this layer or slightly faster than this layer, so it would look really in front of everything else. Also, I mean, you could do other things with this. So in fact, before I finish, I'm going to try shifting this up as well at the same time. So let's get rid of that raster time thing. That's kind of hurts my eyes, that stuff. And where our char is shifting, which is this one here. So we're shifting our char to the right twice, but now we're going to, again, this I'll leave this file in here because this is really useful. You can come in here and you can copy these routines out. Just change these values obviously to the values of the character that you're trying to scroll, but you can just copy paste them in, so you don't have to think too much about them. If you want an explanation for them, just go back to the beginning of the video where I described what I'm doing, and you should get an idea of what's actually happening here. They're quite it's quite a simple routine. It's not complicated at all. There we go. We've got some scroll going on. You're getting network errors. I've not had any problems this side. Yeah, if you had a side scrolling, you would have a perfect intro as well. Although to be fair, I've stolen the graphics from an intro. But I wanted to do this anyway. I wanted to do something like this, and when I saw the intro for Nebulous, I thought, well, this is exactly what I want to do. I might as well just steal the graphics from this. Yeah. Oh yes, it did. Yeah, you're right. Of course. Yes, I'll show you that actually. So, what Booney's on about is if you look at the intro, that like the main menu, the attract sequence, as I've been told it's called, to learn these things. Intros means a whole different thing in C64 world because of crackers. See, I was thinking within the map, within the actual game, but in the game there isn't another static layer. But Booney's right, in the intro, the attract sequence for Limbo's Quest, there's a high score table, and it's made completely out of sprites, so they can keep scrolling everything in the background. So you'll see on here, I put it on this mode so you can actually see when it appears. And you can see the sprites that build it up. So they're using a multiplexer to build enough sprites that they can store a high score table in. So the local Twitch server issue. Okay, well if you've missed anything, we'll put this. Well, the VOD will be on Twitch, and I will put the video onto YouTube once I've caught up. I'm almost caught up with the video, so it shouldn't be too long now. So you see, once it goes into the map, it will display the high scores. You see, there's a lot of splits going on here for various things. Interesting as well, they've made the System 3, the System 3 kind of spheres are made from sprites as well. When it switches over. Oh, cool! I might have to go and see that. Yeah, so you can see there that this is made. This high score table is made of sprites here, which is a really cool way of as Booney says, getting a static layer over the top. It's interesting to look at that effect when it's when it's not on the right character set. Okay, cool. Yeah, I think we'll call it a night there, guys. I will track down. Oh God, I can't even say that name. So, Kyo, he said, wasn't it? Right. Let's try and raid. How do I do it from here now? Channel, is it? Maybe no. I can't remember how to do it. They've changed it all now. Raid channel. There we go. Yeah. So we'll go and raid Kyo. Say hi to him, guys, and I will see you guys on Saturday, where we'll actually get back to doing the game again. We're going to implement the I need to look at the graphics. There's been some graphics posted in Discord. I've still not looked at them. I will look at them at some point, but we're definitely going to implement the crown mechanic as well. Thank you, Diffrizzle, for the follow, and I'll see you all you guys on Saturday. So let's start this raid. How many we're raiding with? I can't see. Oh, 38 ready to raid. Nice. Still like that. Yeah, thanks guys. It's been a fun one. I do enjoy doing these kind of more technical dissects rather than just kind of trying to patch a game. I'm not a cracker. I'm not going to start looking for cheats all the time. I do prefer doing the kind of technical dive and showing how these things work. So, yep, cheers, and I'll see you all on Saturday. Bye.